In this video, we're going to find terms of a geometric sequence, and we're going to do it looking at 6 examples. We're going to start at the bottom. When we look at this, we can see that there is a pattern to these numbers, right? And as we look at each number, we can tell that it's getting bigger, and it's actually getting bigger in the same way each time. This is a geometric sequence because it's getting bigger by multiplying by 5 each time. And so if we want to continue the pattern, we just go ahead and multiply that by 5. So 625 times 5, a little bit of fancy math, and what does that end up giving us? 3,125. In this one, we still have this geometric pattern that's happening. But this time, what is the pattern? It's not multiplying by 5, it's multiplying by 4. It might be hard to tell, except that it does do it consistently. What makes this a little bit more difficult is that we're missing one in the middle, but that's okay because if we multiply that by 4, we get 16, and that still works for our pattern. When you have geometric sequences and we're multiplying, one thing that you can end up doing is you can end up changing the sign by multiplying by a negative. So what would you need to multiply 5 by to get to negative 20? And so you multiply by negative 4. But if we multiply by a negative, it ends up being a positive. So it's going to have this alternating pattern where when we multiply it by a negative, it's flip-flopping from negative integer to positive integer each time. So you can see that these are multiplying by negative 4 each time. We kick it up a notch when we do fractions, okay? But fractions aren't meant to be scary. We can notice that the denominators are all the same. So guess what? The denominator is still going to be the same on the next number. Except what's happening in the numerator? The numerator is multiplying by 3. So if we multiply 27 times 3, we end up with 81. At this point, it is worth noting that it does want us to simplify if at all possible. We're going to leave it just like this because it doesn't simplify. The reason I know it doesn't simplify is because if it did simplify, then it would have simplified one of these times before here too. On this one, let's be more precise on the way we deal with these fractions, because at first glance you go, oh, we're just multiplying by 1 across the top, but then you'll notice that we're not multiplying by a whole number on the bottom. So we need to deal with this fraction a little bit better. So if we assume that this is a geometric sequence, it's multiplied by something each time, then what we're saying is 7/8 times some fraction equals 7/12. Okay, so the question is, what is this missing fraction right here? I'm going to put an X for our missing fraction. So in order to solve that, we're going to go ahead and clean this up a little bit. Notice that we can cross multiply and divide and do all this stuff. And so if I do 12 times that, I end up with 84x equals 56. Now, the number one most scariest part of this problem is the fact that it's dealing with fractions, and that scares people. I want you to notice that the geometric sequence of multiplying by something isn't scary, but the fact that it has to do with fractions and you have to think about something you should have learned a long, long time ago makes you start to shake a little bit. Now, at this point, we start saying, well, I'm trying to find x, so I'm going to divide both sides by 84, and I get x equals 56 over 84. And that's kind of a weird thing. And so the question becomes, can we simplify that? What can we take out of both of those? And the answer is actually 28. We can take a 28 out of both of those, and that equals 2/3. So if we were to go back and look at this and see what's happening here, if we multiply each one of these by 2/3, let's do that with the next one. What is 7/12 times 2/3? And why did it end up with a 7 on top? And well, that's because we ended up with a 14/36, and we can take a 2 out of the top and bottom and become 7/18. And so we're simplifying this, and so it ends up looking like we're just multiplying by 1 on top, which we're actually multiplying by 2/3. So our next number in our sequence, we're going to go back up and look for our next number. And so if we multiply by 2 on the top and a 3 on the bottom, then what we're going to end up with is 14 over 27 times 3 is 81. And can I simplify that at all? Nope. That last one might have scared you. Okay, so let's tone it down in this level 6 problem here. Notice that we have common denominators, and it's kind of the same thing that we had in the last one. Well, it's to recognize that there is a pattern that's happening. It is actually pretty straightforward right now. We can see that it's getting bigger if we look at that set of 3 right there. So it's getting bigger by just multiplying the top by 3. So it's multiplying it by 3. So our common ratio, what are we multiplying by each time? 3. Why did it cancel out to begin with? Well, that's because we had a 3 that we could cancel out in the top and bottom. We didn't have any more 3s, so it couldn't cancel out anymore. So we're going to go ahead and find the next one by multiplying 18 times 3. 18 times 3 is 54. And so we end up with, that is our answer. Thank you so much. I know that the fractions get scary, but again, we're just looking, what can we multiply by each time and to get the next number in the sequence.